European Organization for Nuclear Research (CERN) announced that they had discovered a new particle. The particle had mass but no electrical charge and decayed into smaller particles as soon as it was detected. The particle was the Higgs boson, or more famously, the God particle. But what exactly is the Higgs boson? And why is it called the God particle? We often hear it said that elementary particles are building blocks of all matter. However, our modern understanding of laws of physics suggests that particles are not discrete particles or blocks. Instead, they are continuous wave-like entities spread throughout the space. We also have a name for these entities: fields. You may be familiar with electric and magnetic field. When a ripple or disturbance forms in this field, we call it a wave, an electromagnetic wave to be precise. Visible light, X-rays, and radio waves that let you talk on the phone and use Wi-Fi are all the examples of electromagnetic waves. Hypothetically, if you could zoom in on electromagnetic waves, you would see that they are made of photons. That's why we say that photons are the fundamental particles of electromagnetic waves. The same idea applies to the other particles too. For example, there exists an electron field that is spread thinly throughout the space. Ripples in this field get clustered into a bundle of energy, and we call these bundle of energy electrons. Similarly, there is a quark field, a gluon field, a Higgs field, and so on. Now, quantum field theory, a theoretical framework that brings together the ideas of quantum mechanics, special relativity, and classical field theory, dictates that the universe is filled with quantum fields. This theory argues that every particle can be represented by a wave in its corresponding field. In their 1964, Peter Higgs, Francois Englert, and four other scientists proposed a rather unique idea to explain why certain particles had mass. They hypothesized that entire universe is filled with an invisible, all-pervading field that gives mass to elementary particles. The field in question is called Higgs field. A wave, ripple, or disturbance in that field is therefore called Higgs boson or Higgs particle. This theory suggests that particles don't have a mass of their own, rather they get their mass by interacting with the Higgs field. How heavy a particle will be determined by how strongly a particle interacts with the Higgs field. Electrons, quarks, and other elementary particles interact with the Higgs field in different ways and therefore have different masses. Photons, however, don't interact with the field and thus have no mass. Now remember, the existence of Higgs field was just an idea proposed in 1964 by a few scientists. After initially facing skepticism from the scientist community, the idea was later held a brilliant one. However, for many years, it was exactly an idea that changed on July 4, 2012, when researchers at CERN confirmed the existence of this mass-giving field because a new particle, Higgs boson, had been discovered in the Large Hadron Collider. The LHC accelerates photons and charged ions at a speed close to the speed of light and then smashes them against another beam of elementary particles. Unfortunately, the Higgs boson doesn't sit around for long. In fact, it decays into smaller particles almost as soon as it's detected. There are many stories as to why Higgs boson is called the God particle. Researchers believe it's responsible for a Big Bang that forms our universe, and given that the Higgs boson imparts mass to everything, it has been named God particle. However, note that the Higgs boson is not the sole reason for everything has mass. The Higgs boson helped push the limits of a modern understanding of particle physics along with their conception of the entire universe and its mysterious beginning.